So, welcome everybody, and thank you for joining us at this second European user workshop, European perfSONAR user workshop. Today, we will have several presentations. I will go through the agenda briefly, but before that, I've sent to the chat the link to the wiki location where we have the agenda for both days and where we will put all the presentations. As I said, this workshop is recorded and the video is going to be available on YouTube probably a day or two after this workshop is over. We just have to give some time to people to be able to edit it. Please mute when you're not speaking, or I will have to mute you if there is some background noise coming from your microphones. We will have, I will show the agenda briefly, but we will have a Q&A session at the end of each of the sessions. Today we have 3 different sessions divided by coffee breaks. And at the end of each session, we will have a Q&A session where you will be able to ask presenters. But if you have some question or something comes up to your mind during the presentation, please type the question directly to me or to everyone in this chat, and then I will, after all the sessions, all the presentations in the session are over, I will repeat that, and then we will ask our presenters what you want to hear. So, as I said, we have 3 sessions. In the first session, we will have 3 presentations from Antoine, Duncan, and Eugene. You will hear something about the first perfSONAR workshop that was held in London almost 2 years ago. The second one is going to be about network troubleshooting in GÉANT network. The third one about the use of perfSONAR in Armenian ASNET network, and then we will end this first session with a coffee break. Second session is going to have 2 presentations from Ivan and from Marcos about some specific use cases and experience in RMP network and how to monitor TWAMP, basically latency and jitter monitoring using Juniper routers. And in the third session, we will have our guests from the United States who will who will have 2 presentations. So thank you for joining us, and I think we can start. So I will stop sharing my screen now, and I'm giving the floor to Antoine. So Antoine, please share your screen and start the presentation.
Yes, so hello everyone, and welcome to the second European perfSONAR user workshop. So I think you can see my screen, my presentation. Yes.
Yes.
Okay, good. So I'll be presenting what's new with perfSONAR since the last workshop we had. It was about 2 years ago. It was before the pandemic, so we had the chance to meet each other, and it was in London. And we had called this event the first European perfSONAR user workshop. I think, if I remember correctly, we were about 20 people in the room, presenters and participants, and some more people remotely, probably about the same number. I'm not sure exactly, and I couldn't find the reference numbers as, to tell you that, but I think it was something like that. And I think some of you present today were already present in this this first workshop. And if you remember this this moment and this this workshop, you asked that we do it more often, or that we do it again. So this is why we're all here today, and we organized this workshop because you asked for it. So I hope it will be as useful as the first one we had, but we'll hear about conclusions tomorrow. So what has happened in the perfSONAR world since the last workshop, since June 2019? We have had some new releases of perfSONAR. So back then it was still, we were preparing for release 4.2. And now, if you're up to date with your perfSONAR installations, which I guess you are, you should be running perfSONAR 4.3.4. So that's two major releases that have been out. What we call major release are the second number in the release numbering. And it has brought some new features that I will go quickly through a bit later in my presentation. But also since then, we had a new website and a new logo. This is what you can see on the slides that we will use throughout this workshop as well. But also some other important event happened in the perfSONAR world, let's say. We had the first perfSONAR Day that was hosted by Internet2 at the end of last year, and that was quite successful and very interesting with a lot of presentations. And there is even a recording of that if you couldn't attend. If you go to the YouTube channel of perfSONAR, of the perfSONAR project, you can find recording of that. We also had a new partner joining the perfSONAR international collaboration. This new partner is RNP, the Brazilian Research and Education Network. They have already been involved with perfSONAR for a lot of years, maybe even nearly from the beginning, but they are now joining again with involvement in the development of the perfSONAR software, and Marcos will talk about that later today. And we also had of course, a lot of discussions, meetings, calls throughout these 2 years, and some development work done. So thanks to that, we can now have a look at the newer or the status of the deployments that we have of perfSONAR around the world nowadays. It's a bit more than 2,000 public nodes that exist, and that are I think more the dispersion of the location of perfSONAR nodes is getting more across the world since a few years. In the past, it had been mostly in the United States and a bit in Europe, and Brazil, yes, of course. But now we're starting to see really perfSONAR deployments all around the world, and that thanks to different events and training that has happened in the last year. And even if we look to the European map, we can see that the same kind of movement appears, where we have deployments in nearly every European country and or the larger Europe, let's call it. So that's really great, and that's thanks to you. So thank you to every perfSONAR node administrator to make this possible. And this is only the public nodes. So we know as well that there are private deployments, and those don't show here on the map. And so now let's have a look at what happened on the software side and have a look at the latest release that we had since the last 2 years. So on our website, you'll find a timeline of the perfSONAR project history, and those releases are all mentioned there. But what's worth mentioning and noticing is that we're currently averaging a new release every 2 months. So with one major release, so that's actually our target, to have at least one major release a year, and any bug fix and security release as it is possible. When it was the release of perfSONAR 4.2, the main new feature we brought was the psconfig web administration, so PWA, which is a new graphical user interface that you can use to generate your psconfig deployment file. And there were some new plugins for pscheduler as well to do some new measurements. And that was also the time where we retired BWCTL that was still maintained from the older version of perfSONAR. perfSONAR 4.3 was released by the end of last year. It was mostly a stabilization release and to work on our technical depth, so to port all the perfSONAR software to Python 3. So no big changes happened there, but still some performance improvement and some small features. We also released initial support for Debian 10, but only for the test point, because we have some other technical depth that we need to take care of. And we'll speak about that later today and tomorrow. And some new pscheduler plugins. But now let's have a closer look at the first European perfSONAR user workshop that we had in London. So you asked for a repetition of this workshop, but if we look at the conclusion of the workshop, we also see that you ask for new features and improvement, and you ask for better documentation and some training and some help in deploying and managing perfSONAR. So we tried to work on that and to address your requests. And this is some work in progress. But let's talk a bit more about all that. So if we look at the list of improvement and requests that you had, we can gather that into different teams. I think there were 5 different ones. So one was clearly about improving our documentation. Another one was to, and I'll refer to that later with the docs mnemonic. Another one was about having an easier setup and less maintenance of perfSONAR, and I think we addressed that, or partially at least addressed that through some automation that we developed recently or in the past 2 years. So I will present you that as well. There was a team about improving MatDash and visualization. So that's also something we're currently working on. And then there were a team with engagement or us developers or us, the perfSONAR project, getting more involved with you, the users. So this is something else we're trying to work as well. And some other requests formulated during the workshop were more specific. So I had a go through all the actual recommendations that we listed, that Ivana actually compiled at the end of the workshop the first workshop. And if we go through this list, this is what we can say. So the mesh activation process, I think we greatly improved that through some automation and mostly with Ansible. This is something you have now that's available for you with perfSONAR, some Ansible playbooks and roles. Documentation about the installation, we are working on that continuously, let's say. We're trying to update and improve the documentation with every perfSONAR release. So this is something that's in progress. And as well, the error messages that are printed or that are logged in the log files, we worked on that as well, and we improved it a bit. There's probably a lot of room for more improvements, but we are working on that. And yeah, that's about the same, this one. So how to configure the individual tests and their parameters, I think maybe we improved a bit the docs, but mostly this is something we still need to address in the future. About MATDASH, and there were a lot of recommendation about MATDASH. We are working on a complete overhaul of our visualization options for perfSONAR, and so this is something we're going to present tomorrow with the trying as well to address that. With the change to MATDASH and the visualization, we hope we can address some of our requests, that recommendation that you formulated during the workshop too. And for the new alerting with OTRS, we didn't work on that because MATDASH is going to change, but hopefully this is something that we could work on in the future. So there were more recommendations, all that. Actually, there are 4 different slides about that. I'm not sure I will go through each one of them in details, but they are listed here for the sake of completion. So there you'll see that all of them go into this different theme that I listed first. So the visualization, the engaging with our community, the automation to help you deploy perfSONAR, and then some other tools. So if you're interested in reviewing all these recommendation and see exactly what has been addressed, you're welcome to do that. My presentation is available for download on the wiki. If I go into very much details now, I think we will lose a bit of time. So, but there are different things that we're definitely working on and that we'll be presenting you today, or that we hope we can present to you in the coming month. You'll hear about updates about all that during this workshop. And this was the last one. You see that there are a lot of things are currently in progress. Some have been addressed correctly, but this is where we're going. So to recap a bit on that, so for the improvement to documentation and help, as I said, we regularly update the documentation. We have some new quick sheets as well. So there is a complete guide for the psconfig web administration that's available for you on the perfSONAR website. And I guess some of the presentation today and some webinars and info shares we had in the past are also not quick sheets, but recording that can help you install and manage perfSONAR. And all that is collected and available on our YouTube channel. We have worked on improving the setup and the maintenance of perfSONAR through the new Ansible roles and example playbook. So now you have available an example playbook that you can extend and take as a starting point to deploy your perfSONAR host and to maintain your perfSONAR hosts in the long term, and to reinstall it and to add more nodes to it very, very easily. And there is also some improvement that have been done to pScheduler so that the services are automatically restarted in case they're crashing or failing for some reason or after some time. If we look at the topic of improved visualization and all that's about MatDash, one thing that we'll be presenting tomorrow is the perfSONAR 5 release that we are looking at the moment and that we're working on, where we'll be completely changing the backend, and thanks to that change also bringing a new front-end possibilities for perfSONAR, and that's based on Elasticsearch and Grafana, two tools that are widely used in our community. So we hope that you'll be able to make good use of all that. And there is also another tool that we're currently working on, and that but that's still work in progress. That's a new graphical user interface for on-demand measurements. We currently have throughput, latency, and round trip time. And at the workshop 2 years ago, we actually presented our plans and the reason why we were working on that. Hopefully, we'll be able to present you a beta version soon, and we will have a demonstration of that at the next TNC. And then some more requests were about adding new measurement type, and for that there is the plugin development toolkit, the plugin development kit that's available, and that Mark will explain you about tomorrow. And we also been involved with some other projects, mainly the Lola project, to see how perfSONAR could be used to measure jitter with TWAMP or with other tools. So this is also things we're working on, and that Ivan will actually talk about as well during this workshop. And there were some other requests. So yes, we know some of you asked for running perfSONAR on BSD. We're not there yet, but we will be mentioning the OS support and asking you your feedback about which OS you want perfSONAR to run on during the workshop tomorrow. So we've been tracking all that progress through our usual tools on GitHub, the issue tracker, announcing the new releases on our new website and on the mailing lists. And we tried to be more involved and more engaged with you. Unfortunately, the conditions since about a year has been a bit difficult to do a lot of things about that, but still, I think we had quite a lot of online events that were useful. So yes, that was the introduction to our second European perfSONAR user workshop. So today we'll mostly focus on user experience use cases that will be presented by actual users of perfSONAR. We hope that they will give you insight in how you can use perfSONAR, maybe in different and innovative ways. And that will be useful to you. And then tomorrow on the second day, we'll talk more about the development side of perfSONAR. So that will be presentation from developers, but towards you users. If you want to know more about new features, work in progress, that will be mostly for tomorrow. So thank you for listening to my presentation, and we'll take questions at the end of the free presentation we have now in the first session just before the break. So I will now hand over to the second presenter, which is Duncan, I think.
Hello, can everybody hear me and can you see my screen?
Yes, all is good.
Okay, so I'd like to talk today about an example or a use case that we had when we used when diagnosing some problems that we saw on the GÉANT network. So my name's Duncan Rand. I work for Jisc and I also work for Imperial College in London. Sorry, there we are. Okay, so just a sort of introduction. Researchers, academic researchers are relying more and more on good network connectivity to carry out their work. And the data sets that they're transferring are growing in size year on year, which makes the timely transfer of this data increasingly more difficult. The rates are going up. But the global research and education network is made up of a disparate array of different networks, owned, funded and operated by independent organizations, although they do communicate with each other. So these networks need to operate seamlessly in order to enable research collaborations to operate successfully. And where do we go? How can we go about diagnosing things when they go wrong? So I'd like to base this around an example, and it comes from some work being done between Hawaii and the UK. And it's a part of a project called the Atlas project. I work in the LHC, so I'm more used to Atlas referring to one of the experiments on the LHC, but I guess it's a common acronym. In this case, it stands for Asteroid Terrestrial Impact Last Alert System. And there's a URL there. It's an interesting project, and they're basically trying to detect asteroids which might impact on the Earth. And there's quite a sort of dramatic quote that I list there. So in this case, in our example, they're transferring some of this data from the telescopes at Hawaii to Queen's University in Belfast, which is in Northern Ireland. To state the obvious, Hawaii is a long way away from Belfast, about 11,000 kilometers, and the round trip time is 180 milliseconds. So we got an email in which the researchers had encountered a problem with their throughput, and they were experiencing significant drops. And this meant that they were unable to transfer their data in time to keep up with the schedule of data copying. And what was interesting and frustrating for them was that this was an intermittent problem, which is often termed a soft fault. So this is an example really about diagnosing soft faults. So there's a pretty picture of Hawaii and Northern Ireland, or the UK, and you can see this is obviously the ASNET perfSONAR directory map. You can see a lot of perfSONAR hosts in the US, and indeed a fair number over in Hawaii. There's quite a number that they've installed over there to help diagnose this type of transfer issues. So transferring data at high throughputs over long distances is made hard by the fact that TCP-based transfers with with high latencies are sensitive to packet loss. So we need good monitoring to understand any problems or what's going on. iPerf3 can be used to simulate typical data transfers, memory to memory copies, and a typical time is 10 or 20 seconds. You can also use tools such as ping to measure latency and packet loss. And traceroute shows the routes taken between hosts, because obviously there's quite a number of hops usually for such long distance. And it's useful detecting asymmetric routing, which can be a problem. So perfSONAR is very useful in this type of work. And it's a tool for the automated collection of similar or such network characteristics. It's open source and free measurement middleware, installed on Linux hosts, which test against each other. And it should be located alongside data stores and transfer nodes. So it's used to find network problems, and such as this soft failures. It's designed to work in a multi-domain environment. And usefully, you can form meshes of perfSONAR hosts which can test against each other. So the usefulness of perfSONAR is maximized when the hosts are installed in good time, before problems actually occur. This allows you to generate a time history of chosen metrics and how they fluctuate. And it's easier to use this time history to troubleshoot than trying to run iperf, for example, manually when the problems actually arise. And it's often the case that the change, as well as the absolute magnitude of metrics, such as throughput or loss, is valuable. You see that it's not as good as it used to be. So the ATLAS project were organized in this respect, and they had previously set up perfSONAR hosts, certainly at Hawaii, as we saw, but we helped them install one in Belfast, and they have others in places like Baltimore on the east coast of the US, in intermediate places. But I think it was the one in Belfast, which was actually a small host, only 1 gigabit, a small box, which was moving things forward. And these are all in this ATLAS perfSONAR mesh, and this is just a screenshot of one of the grids, and you can see a number of 10 gigabit hosts in Hawaii, and there's also one in Slough, the Jisc one in Slough. So I've pointed here to one measurement in the intersection, and it shows that typical throughput from the Institute for Astronomy, IFA in Hawaii, to the Jisc host is about 3.3 gigabits a second. So that's quite good, I think, considering the distance. And these are using, well, at least the Slough host has jumbo frames. I forget whether the Hawaii perfSONAR hosts do as well. So just a bit about intermittent or soft faults. These can potentially be a significant problem because they're difficult to track down. Hard faults, such as a cut in the fiber or a power failure, are easy to detect, but soft faults in which you don't have a total failure can remain undetected for years. These can be caused by congested or faulty links locally within the campus, or indeed between domains. They generally cause packet loss, and that results in degraded TCP performance. Sometimes the problem is actually local, but only appears when interacting with more distant hosts, again, such as Hawaii, because TCP, as we know, is more sensitive to higher latencies. So thanks to ASNET here, and if you want more details on soft faults, I recommend the fasterdata.es.net website, which is a treasure trove of information. So this is what we saw when we investigated the perfSONAR trace after receiving an indication there was a problem. So this is the throughput between Hawaii and Belfast. And you can see that the average there is an adequate throughput of about just under 600 megabits a second. But there, the other arrows point to significant drops in the throughput associated with a red purple dot at each low point, which indicates that there were retransmits of the packets. So something clearly going wrong there. And this happened, incidentally, August last year. August the 9th is the date listed there. So when we looked at some other perfSONAR traces, in this case, they're both within the Atlas mesh, but not specifically Hawaii and Belfast. We saw similar drops in the throughput, and so this indicated that it wasn't necessarily, well, it wasn't specifically the two endpoints where the data was being copied that were at fault. So this graph shows more of the perfSONAR hosts, and what you can see over a longer time scale is that there's a gradual worsening of the drops in the throughput. They start off just dipping below the maximum there, but they increase between June the 28th and between and middle of July, late July and early August. So this is I think typical of this type of soft fault where there's a degradation in performance. The increase there that you see in the baseline was caused, I think, by us tuning the TCP buffers on the Slough host. That's what I seem to remember. So along with drops in the throughput, we noticed a continuous packet loss. And you can see it there at this relatively low level on the left-hand side, apart from, ignore the spike, but it increases towards the right-hand side. And this was between a GÉANT perfSONAR host in a London data center and the Jisc perfSONAR host in Harwell in Oxfordshire, Didcot Harwell. So this indicated that it was the problem, allowed us to narrow down the problem somewhat. And we asked the GÉANT NOC to investigate. And they replied quite quickly to indicate that there was a faulty optic in the 6x100 gigabit aggregate between London Harbour Exchange and London Powergate on the GÉANT network. So this plot again shows Baltimore to Slough, and I've indicated there an arrow where they removed the faulty link from the aggregate, and then the drops disappear, the dropouts disappear. And similarly here, the continuous packet loss disappears at the same time. So in conclusion, the diagnosis was a faulty optic in the aggregate. Monitoring that simply measures traffic levels on interfaces won't pick up these types of issues in the way that perfSONAR can. And we used a number of different perfSONAR hosts around the world to help diagnose the problem. So a good distribution of nodes and intermediate nodes can help work out or narrow the problem down. It was relatively easily resolved once diagnosed, and the customer was happy and able to resume the copying of data from Hawaii to Belfast. There are more examples of soft failures on the faster.net website here. So just a couple of extra slides on some other aspects of work that we're doing. A number of sites, or we're seeing sites now within the UK having their connections to the GÉANT network upgraded to 100 gigabits a second. Two examples are Imperial College, where I also work, and the Rutherford Appleton Laboratory in Didcot. They've both been upgraded. And so we now have a requirement to start testing with perfSONAR at rates that are greater than the 10 gigabits that we've previously has really been the maximum. So we've installed a 100 gigabit per second testbed in Didcot, which we're gaining experience with maximizing the throughput that we can get between perfSONAR hosts and data transfer nodes, etc. And Imperial College has joined the WLCG 100 gigabit per second perfSONAR mesh. which I list the URL and a screenshot from. So we provide services to GÉANT connected members as part of the end-to-end performance initiative. So a sort of summary of the services we provide include the perfSONAR host that I mentioned, which is part of the GRIP-EP mesh, GRIP-EP being the UK part of the WLCG, and a 10 gigabit per second perfSONAR for ad hoc testing, which might still be desirable. That's iperf-10g.ja.net. And also a 10 gigabit DTN, which runs Globus software and a GridFTP server. And also a RIPE Atlas probe. So if you'd like to, if you're interested in discussing any of these things or anything else in my talk, then that's the email address for Tim, myself, and Raoul. And I think that's, yes, that's the end of the slideshow.
Thank you, Duncan.
Thank you.
Thank you for this presentation. The third presentation in this first session is from Eugene Prokhorenko from Armenian Research and Education Network. So, Eugene or Eugene, please share your screen and start presenting.
Okay, hello. I just wanted to warn you that it is not so nice presentation, but this is what I could do for some days because I was busy with some project about VPNs, and now I want to tell about perfSONAR and what we are using it and what are the problems and advices to the authors. Okay. At first, I see perfSONAR 7 years ago. Who can remind me where perfSONAR started?
Well, the perfSONAR project started about 20 years ago, but the first software was maybe 15 years ago, something like that.
Okay, thank you.
We will share very soon in the chat the history bar that Shimon created and is currently available at the perfSONAR website.
Okay, so let me also, how can I share my, okay, no video. Now, and when we got first perfSONAR, it was we were so excited that we didn't touch even this device because it is something new, something unclear, and it was already programmed to test some points in Europe by I think the authors did this test configuration, and we were trying how to find a way to check our other points where our users are using to get much traffic. And for ASNET, it is DAISY in Germany, and it is also in Switzerland. It is the you know, yeah, and also some points in US, because we have here in Armenia Physics Institute, which have contacts with the main physics institutes over the world, and they need to have good speed to download data from accelerators. Unfortunately, Physics Institute now don't use their accelerator because energy is too expensive. So they just only help to work with the data getting from other sources. Now, I contacted GÉANT when we got this PerSONAR and asked them what can I do with this device, and they contacted me with the PerSONAR team, and we just registered a mailing list and got needed help, and we got some results from the monitoring, but it was hard to analyze what does this mean. Even this year we have some problems with the just TCP packets, and it's interesting that when we are testing just link is it looks okay. We have a direct connection to the GÉANT, and we have also connection to the some ISP in Europe, and we see that pings are good just up to the end of the cable into Frankfurt, where it is last point, and then we have big packet loss, like from 50 to 80%. It is not what we can have, and we have such situation for some maybe years of minutes per day, and the other day it is fine, and everybody are happy. So now we try to find out if the problem is in the hardware or in the software. For hardware, I read all what I could find in the for the iPerf. It was that time only iPerf 2. Now we have iPerf 3, and it appeared that to have very exact results, you need to have special network cards. For example, there can be D-Link cards like E1000 with some special numbers after, and only in this case we can get precision, big precision. But in practice, we don't need such things. It only may be interesting when we are checking links not so long. For example, we have some sites now in our NREN. Everything was started with the 2 sites, and then sites are added, and we have now like now already seven sites, and to every site we have cable, and we want to have information about quality of the link. So we just put PerSONARs on these points. It is star topology, and they are at the end of the star, and we are getting information and trying to figure out what is the problem of some events. And also it's interesting that our two main sites has not one but two links. They are going through different paths for to have ability to use it as backup, and in this case, into the for the perfSONAR, it depends on the OSPF settings, because between two points, our perfSONAR traffic can go in different ways. So maybe today I have traffic for one line, and the other day the other line. That is what was how we started our activity in this way. Then what is negative features of perfSONAR for us? For us, we at first find out bad situation with our MATDASH. The problem is that we had very old installation, and everybody even don't remember who and for what for did it, but it is strange that it was working, and we even could change parameters for the current configuration, and it worked. But now it was built on so old operating system. It is like CentOS 3 or 4, and when we wanted to update it to other operating system, again to the CentOS, we couldn't do this. And so we are trying to find out what can be done to revive this machine. It's interesting to know that despite of ton documentations of perfSONAR, for every year it's harder and harder to understand some important instructions. And it is definitely connected to the increasing programming level of perfSONAR team, but hard for users, because when you compare documentation for different versions, in the last versions they are using more technical language, and even some networking people can't understand all these parameters. Okay, that I also already told. I want to tell that for now I just can prove the idea that there are really some problems with the perfSONAR, and that authors are trying to do their best. But for example, new features that we were talking the last meeting, I couldn't find it in the last documentation that is on the site. I hope that in some day they will go. That they will have. They will be there. Now, let me also add some things. Can I? Yeah. I just made some marks. First, documentation mainly oriented to new installation. And if you want to keep your old data, it will take much time. We heard that this will be changed in the nearest future. Very good. And if we want to install a perfSONAR as virtual machine, it is not clear what in documentation the author mean, which IP addresses, because we have some different installation, like at first cluster, the second is some OpenStack device, and some other devices which has a different type of virtual machines. And for each case, it is not easy to tune and to install perfSONAR. It will be good if we will see more information about that. And I already told about MedDash. 3 people were reading 3 times the documentation and couldn't пролить свет. In Russian, it is shed light on the questions where data goes and when they goes. We need some more explanation. And last one is that it will be easy to have simple pages. For example, if you are talking about some complex question, at the end of this discussion or documentation, you can insert a simple page where you just have the recite. Do this, do that, and that is all. But you do vice versa. When you read the documentation, if you see some text of the other color, it means that it is more complex than the whole text. Okay, and also I have some more additions, what I just had in the in this time when I heard the previous talkers. So I tried to find out in the perfSONAR the name like EFI bias, because some our perfSONARs are built on the hardware with this bias, and to have correct installation, you need to do some tuning for the perfSONAR, and I didn't find this in the documentation. Also, one question is about firewall. As far as I understand, if we will just don't touch some set of ports, we can do everything with this hardware. I want that perfSONAR will prove that it is correct, because sometimes you don't know what is going on. If you see some that somebody try to get your hardware, we see many attacks to our perfSONARs, and sometimes it even just do the perfSONAR will stuck after this attack. When we then restart, we see that it was somebody who have attack on them, and so it is. We want not to allow somebody to do such attacks, and we want to change firewall, and it is good to know that we can do this without changing setup for perfSONAR. Then it is interesting that perfSONAR gave a good link to the tuning TCP stack for all computers. This is very interesting link, and I learned it by heart. But now they are changed their focus to the 10 gig connections. And it's good to have PC with the 10 gig connection, but we don't have such things. And it looks like perfSONAR authors think that nobody now need not have perfSONAR on 1 gig Ethernet card. Maybe I am wrong. And the last is that about L2, layer 2. As we know, perfSONAR is L3 product, layer 3, and the question is it a good idea maybe to add something to perfSONAR through the for the L2 check? Because like in our NREN, we understand that sometimes our problems lie in the L2, not in L3. Okay, that is all. Thank you.
Thank you, Eugene. Well, this is an interesting presentation in the sense that we heard some feedback from a relatively new user. Do we have some comments from maybe Antoine or Shimon, who was working with the documentation, about some of the claims that we heard in this last one?
It was question?
Yeah, to Antoine or Shimon, if they'd like to comment.
Yeah, so well, I can try to answer some of your questions or the points you raised, Eugene. But I think yes, the documentation, we can still improve it, and there's always room for improvement there. But one thing I wanted to mention is that nowadays, with the new installation methods and management methods that we put in place with perfSONAR, with the Ansible automation, but you can also use different tools for your automation and deployment if you want to. We rather recommend reinstalling new perfSONAR anew and from fresh whenever a node is malfunctioning or is behaving like it shouldn't. It's it's usually easier and less time consuming to reinstall a new node, or to erase the one you have and to bring up a new one, than to fix a running one. So, but for this to work, of course, you need to use a central archive, and consider your perfSONAR node as disposable. But with the new tools that we have, with the PWA, with pScheduler, the way it is managed, you can have all your configuration that's not stored on your perfSONAR nodes, and installing and having a perfSONAR node doing some measurements is just a matter of running an Ansible script, an Ansible playbook, and you can be done in half an hour and have your perfSONAR node replaced. So that's what I would advise to do nowadays with perfSONAR, and the way I would advise you to install your perfSONAR nodes. About the layer 2 measurements, as that you mentioned as well. This is something that has been mentioned in the first workshop as well. So we then discussed how what kind of layer 2 measurements we could have. I think we also had during this workshop or at some of our webinars presentation about CFM measurements or things like that. So using tools and extension to the Ethernet protocol. So there are ways to do that. So, well, at least the perfSONAR architecture with pScheduler has some space to bring in those layer 2 measurements. And I think the new visualization possibilities that we'll be bringing on in the perfSONAR 5 will also help with regard to that. But we also don't have many spare cycles to work on all that and to integrate new plugins and measurement tools to perfSONAR ourselves. So that's why we also invite you or any users to consider bringing in yourselves the new measurement tools and the new ways of using perfSONAR. And for that, I recommend you the two presentations that will happen tomorrow. One from SUNET, where they developed a plugin to monitor switch ports directly with perfSONAR, and the other presentation from Mark Fate, a perfSONAR developer from Internet2, which will explain you how to use the pScheduler plugin development kit. So that's what I wanted to say, and to try to address some of your concerns.
Yeah, I just may add a few sentences on the documentations. Well, first of all, thank you for all these comments. I think they are very, very good from the perspective of the user, which has been with us a long time, it seems so. And yeah, as Antoine said in the beginning, we are constantly trying to improve and honestly to keep the balance between the amount of documentation and things we try to address. And yeah, we also try to create these quick sheets and sometimes also video where possible. So these are probably the places where you can find some answer. But anyway, we'll I'm sure we'll take account into and be in touch with you to yeah, to note those comments and improve where we can.
Shimon, is there a specific way or place that users can give feedback on bits of documentation they find confusing or unclear or missing?
There are two possibilities, in fact. First of all, is just to send an email to us so that we can note it down. But it's also possible to go into GitHub, and I will try to post a link in a few minutes to the chat. And there is this branch related to documentation, and just create an GitHub issue so that we can keep it in our records and follow with the user directly. So two of them are possible, in fact.
Thank you, Shimon. We have one comment which is also related to this last presentation from Mark. In fact, I don't know, Mark, if you would like to say it, or I can read just.
Yeah, sure. And this will get discussed a little tomorrow during my presentation. But there's nothing. perfSONAR has been a layer 3 product largely just because of history. So it's been, those have sort of been the measurements that people wanted to do. One of the things that was done in the design of pScheduler was to basically is to not have it revolve around a specific set of measurements. So you could actually measure pretty much anything network related or not, layer 2, layer 3, doesn't matter. The architecture is there to do it. And what I said in chat was that in a lot of cases, these newer measurements come to fruition when we have someone who's got a use case and a tool that they're using, and expertise on using the tool and understanding its ins and outs and so forth. I mean, we can help that process along, but we don't have the, unfortunately, we don't have the horsepower to learn the ins and outs of every tool we come across, as much as I wish we did. So we sort of lean on the users, the people who have the measurement problems, to help us out there.
Thank you, Mark. Well, we are now in the Q&A session anyway. So I would like to ask anybody if they have some questions related to also to the first and second presentation from Antoine and Duncan. Also, please pay attention on the messages which are appearing in chat, where Ivan and Shimon provided some infos and links about the places where you can put some issues. Ivan, would you like? Yes.
So actually, I have a question to Duncan's presentation. I saw very nice graphs there, but it appears to me they are not taken from perfSONAR. So it would be interesting what other monitoring solution they are also using there. And as a second question, hopefully an easy one, is that I noticed on the map where it was showing how the traffic goes, or actually, I believe that was the measurement points which were used in the investigation of the problem. So the question is, how did you decide, or how did you find these measurement points? What approach did you use? Because there is no such a service as far as.
Hello, Ivan. So for the graphs, I think they are perfSONAR graphs. I'm not aware of any. I seem to remember taking them from the perfSONAR hosts.
Is there which specific one was it, Ivan, that you thought wasn't?
Well, that is with the.
Can you bring up the deck, Duncan, and just have a look if there's time?
So the ones that the issue was, evolving. Yeah. So is that from the?
I think that's from perfSONAR.
That's perfSONAR.
Okay. It's so
it's
well
just a slice of the full.
Yes. So well cut that. Okay.
It's a screenshot. I mean,
Yes. Okay. I thought it's a different. So then yeah. Then the other question, on this. So how did you decide to use these measurement points, in diagnosing the issue?
That arrow is schematic. I mean, it's just meant to be. I just drew it on relatively randomly.
I see. So it matches several points there, and I thought you used, the one in Nevada and I believe Indiana.
No, sorry, that's just
okay.
It's just a schematic, perhaps. Yeah, maybe that's not right to do.
But then, how did you decide which measurement points to use? In the diagnosis, because you said that you checked different places and then realized that they are also observing these issues.
Right. So the Max in Baltimore is part of the Atlas Mad Dash, on Atlas Mesh. The mesh I mentioned. Is it listed there? No, it's not listed there. But if you go to the website, I think they have a DTN in Max, and the others we just sort of picked them because we thought they might be useful. I mean, this GÉANT and the one in DIDCOT are two. They're two PMP. That part of the GÉANT PMP. Mad Dash mesh, I think, the small gigabyte boxes. So I would say we just looked around until we found things that helped.
Okay, so you got some luck there and some internal understanding, knowledge of it's not because, you know, you didn't look through all of the nodes there in US to make some tests. And
there wasn't really an algorithm. It was, I seem to remember we said, well, I wonder what this looks like and that looks like. But it turned out that most of the, many perfSONAR hosts had this issue, I think.
I think we did look at measurements, for example, between the ASNET international dashboard and some of the other ones from the States into London and into GÉANT, and realized it was something within, certainly within GÉANT, or from the GÉANT entry point towards Belfast. And honed it down that way. But it's very useful that there's the additional points, for example, those additional public meshes of international measurements to help with that.
So actually my point here is, you know, because I suppose most of that, you know, that you just shared, that this makes it a use case, you know, for one good perfSONAR look to trace out.
Yeah, something, you know, a production pea shooter, for example, a like thing, or the type of approach that you've mentioned before, Ivan, those sort of tools to help automate that or to make it simpler would be great. I think Mark is on the call, or was.
I am, yeah.
Yeah, so it's just an advert for pea shooter, I guess.
Yeah, and actually, probably worth mentioning in the pea shooter context is, I mean, we have there's a new thing in 4.3 called a batch processor that will let you do a whole series of measurements and get the results back in mass as it's sort of one fell swoop. So that might if you have other things, if you have other things that are not path involved, which is kind of how pea shooter is, you can do those as well. You can just kind of throw them at perfSONAR as a batch and get the results back, and then do what you're going to do with them.
Yeah, I mean, I think the important thing, and I think Duncan mentioned it on the last slide, was this is a really nice example of something where just looking at the traffic stats and the levels of traffic doesn't help you. But perfSONAR is a really good indicator of the issues. But what we then need are the types of tools that do the analysis of those measurements to spot a trend or a worsening situation. At the moment, it's quite difficult, other than just looking at results, to come up with that. But some more intelligent tools to actually analyze the results over time and to spot problems arising. That's the sort of thing I think we need to be working on more. I know there's some projects doing that, like SAND, for example, and other things within the WLCG, but more of that would be good.
I would expect that when one member of a bundle starts having errors, that any particular test would hash to whichever bundle it hashed to, and that you would get a different behavior on each test, where if you were lucky, you would get a good bundle member, and if you were unlucky, you would hash to a bad bundle member, but it would always be the same. So I'm surprised at the pattern that you saw.
Yeah, well, I guess we could ask our engineers for more details about the specific lag algorithm and how it's working, whether it is consistent or whether it might vary and be seeded in some other way over time. I don't know the details of that algorithm. It is Juniper equipment, if that helps anyone more knowledgeable on the call, but yeah, it's a 6x100 lag. It's Juniper equipment with CN at layer 2.
Hey Tim, for what it's worth, we've bumped into this at Internet 2 as well, and it's
okay.
It's a really thorny problem. At the last time, I think the last time we had any real substantive discussion on it, there was not a great deal. There was really no way to force the traffic down one line of the bundle. So that kind of made testing difficult. And I think our network engineering people are still scratching their heads over what to do about that.
But I think these types of aggregates are not uncommon on NREN backbones.
Oh yeah, no, definitely not. Or
it's not. Yeah. It's surprisingly uncommon to just have pure 100, pure 400, whatever.
Okay, so it's now 2:25 Central European Summer Time. So it's just time for our first coffee break. So thank you all for this discussion in the Q&A session. If you have some other topics that you would like to discuss, we will have 2 more today. So we will restart the workshop at 2:35 Central European Summer Time. That's in 13 minutes from now. So please grab your coffee or tea or whatever you would like to have, and see you at 2:35 Central European Summer Time. Welcome back to the second session of this workshop. I hope you managed to grab a coffee or tea. Our first presenter today is Ivan Garnizov from the Friedrich Alexander University of Erlangen. Ivan will talk about one installation and implementation of TWAMP monitoring in GÉANT network. So Ivan, please start to share your screen and start the presentation.
Hello guys, can you see that?
Yes.
Okay. And so I'm Ivan Garnizov, broadcasting here from Friedrich Alexander University in Erlangen, Germany. I'm going to present you the GÉANT Operations experience in the implementation of perfSONAR TWAMP monitoring with the Juniper routers. Okay, so I'm going to talk about the current implementation for GÉANT Operations and the requirements and considerations there. I'm going to also switch live to the GÉANT Operations dashboard of TWAMP, and we'll see some details of the measurement results, some observations there. I'll talk about the implementation challenges I had with TWAMP, and also with the implementation challenge with RTT tests. Also, we will present here the plans for the future GÉANT Operations dashboard, and kind of some personal observations and possibly thoughts on the perfSONAR future improvements. So the current implementation is came as a requirement to run tests against 37 Juniper routers with TWAMP reflectors. It would have been nice if we could use OWAMP, and I'll talk about that a bit later, but the Juniper routers support only TWAMP extension. The requirement was to have regular testing, a mesh with regular testing, and that should have been non-intrusive to the network, but also non-intrusive to the perfSONAR nodes of GÉANT Operations, because actually these perfSONAR nodes are also there for the benefit of the partners, so that they should allow and be able to respond to partners' requests for measurements. So yes, and then yeah, we needed to have a dashboard with measurement history. So now I'm going to switch to the dashboard. I hope you're seeing that. And this one is actually, as you can see, the 4 new servers that were deployed. Some of them are not that new, but anyway, they are all testing against the 37 routers. Some of these routers just recently are being upgraded, and I expect soon to have the TWAMP functionality brought back. Yeah, nothing fancy here. I would like though to go to the details, and especially I will take the Poznan router because later I will have a reference to it. So now, as you can see, it's the London server towards the Poznan router. I have also activated some latency round trip measurements, which I'm going to disable now. And now these are the TWAMP measurements results. Well, with TWAMP, generally one would expect to have a two-way measurement, meaning that from a single measurement you get the forward direction results and the backward direction results, and possibly also some results based on assessment or regulation of the round trip time. But unfortunately, currently with the current implementation of SONAR, it's not possible to get these. So I decided to activate, in addition to that, round trip measurements. I just wanted to show you that it's, when I disable the forward results, there are no other results. So the reverse measurements are just not there. Although they are being measured, and I will show you in a minute where. So I have activated the round trip time tests, so pink, and now I'm collecting also some measurements, the measurements from the round trip time. Apparently, one-way delay measurements, or the TWAMP measurements, which are one-way delay in one direction and then in the other. They are prone to issues with time synchronization, but yeah, there is room for improvement, and we are going to cooperate with another team to see more into these details, and I'll show you now actually the implementation from another team. This is the time map for GÉANT.org. This is from a team called Lola. It's for the low latency mesh, and this team is actually using a perfSONAR node in London Slow, and is also doing TWAMP measurements with TV ping. Okay, so as you can see here, I have on this graph, I have from the perfSONAR nodes in Slow, London Slow, towards the Poznan router. And as you can see here, we have the sent, the forward direction results, which are here above, and the reflect results, which are the reverse direction. The Lola team actually is not testing to all of the routers, and they are having this perfSONAR node in London Slow. This is why I chose actually on the perfSONAR dashboard the same kind of scenario, the same case. And I would like here to go to the last 7 days. And you can see the pattern here for the forward direction. And here I will switch to also to 7 days, 1 week. And you can see the same pattern for the latency measurements, for the one-way, for the TWAMP measurements on the forward direction. So again, these guys are using a perfSONAR nodes, but they are not using all the perfSONAR stack. They're just using the TVPing tool to collect, to run the measurements and to collect the results. So I'm going back to the presentation. So this is what I just shared and talked about, the misses and the expectations on the graph, the added round trip time tests, and the comparison with the LoRa implementation. So I'm coming here to the challenges that I had with the TWAMP implementation. So in order to kind of be more understandable, I'll switch back again to the documentation, actually to the documentation page of perfSONAR, where you see a classification of the supported tests. And here we have exclusive, normal, background, and background multi-tests. And these define how your tests behave and how your tests are being scheduled and coordinated on the perfSONAR node. With the exclusive tests, these are the only one. These category of tests, generally the throughput tests, they can run only exclusively. So it's not. They do not allow the run of other exclusive tests or other normal tests, but in parallel, you can run background tests and background multi-tests. While with normal, you can have multiple normal tests running in parallel. It's not possible to combine them with the exclusive, but still, you can combine more normal tests together. And actually, here lies the problem, the first challenge with TWAMP, because TWAMP measurements are actually, just a second, so these are latency only measurements. So having latency only measurements against 37 routers kind of saturates a bit the schedule of the perfSONAR node. And here is a calculation that I made, that if I have 37 routers, each of them from a perfSONAR node, if I would like to have a 10-second test and account for some 5 seconds a transition time between the tests, and I do that, I do these 10-second tests every 30 minutes, then that would mean that for 37 tests, I will be having something like 10 minutes utilization of each 30 minutes, which means that 1/3 of the time I will be running normal tests, which will be taking the schedule of the exclusive tests. And the exclusive tests are actually the tests with throughput, which are actually a lot of interest from the partners, and even within GÉANT Operations, we also have a mesh with throughput tests. So that would lead to some collisions. Of course, there's a catch here. I'm sure that Mark gets that, but the catch here is that these are normal tests, meaning if there was a way to somehow combine them, you know, to overlap them on the schedule, then it wouldn't take that 1/3 of the time. But with time, when you start these tests, they tend to spread, you know, on the schedule, and then they leave smaller slots there, and they don't tend to run simultaneously on the schedule. So actually, I have further reduced the time duration of the test to 5 seconds, so that we have, you know, we are taking as maximum 1/6 of the time. I would like to remind you, you know, on the second slide, I have that actually these perfSONAR nodes are also, it's very important consideration to have them as for the benefit of the partners. One minor thing that I had to deal with, it was also with the psconfig, or with the configuration of the repeatance of the tests. You know, it was kind of probably my mistake or my misunderstanding, but I didn't realize until recently that I could use also the sleep run and kind of make this same implementation that is proposed for the throughput measurements, to have the sleep time take a lot of amount of time in order to make sure that these tests happen. Because initially, when I created the mesh, it was quite often that these tests would fail because they wouldn't find a slot because of having a lot of throughput measurements there. So the time synchronization, of course, is an issue with this type of measurements, with TWAMP and all the type of one-way delay measurements. So there is something expected, but just wanted to mention it. And now I'm coming to the round trip time, which is generally, you know, something. It's a type of a background test, but again, I came to a challenge. It's the type of you know, on MADDash, you get with these type of measurements, you get again a loss evaluation. But since I was having a loss evaluation already from the TWAMP measurements, actually I just didn't bother and didn't create yet another matrix. Actually, if you understand a bit more on the background of MADDash, you also understand that I've spared to the MADDash server of GÉANT Operations some I don't know, some 200 tests, you know, which are being run through the Nagios plugin to evaluate the state of the matrix. So that's why I'm having just one mesh there, one matrix, but there's no point of having an additional one once I have T1 loss. So what's the challenge? So there is as I talked here about the categories of tests, there is this difference between background and background multi-tests, where with background tests, you can run them, yes, along with other tests, but the problem is that you have to schedule each one of them alone. And with the background multi, at least it's not that apparent, or it's not that strong, I would say, because we have as a background multi, we have the OWAMP or the pulse string measurements running continuously in the background and providing continuous testing. And for these, you know, I don't have to have that many runs configured, and how many is that? So if I want to have every 10 minutes, that means 6 measurements per hour, with every 10 minutes run a test with ping, I would have 6 measurements in 1 hour. So for 20 hours, I have to multiply by 24. And then on each of the nodes, I'll have to configure 37 multiplied by those. So that means on a persona node, I'll have to have more than 5,300 measurements, which is a lot. And actually, from my experience, when there are so many measurements to be scheduled at once, because psconfig is trying to schedule and then tries again, but this quite often leads to overloads. And actually, I'm also struggling with some file descriptors issues and so on, although I have found my way around that. So this is something for the conclusions page, that I'm going to come with. So of course, with RTT measurements, there is no time synchronization problem, and therefore they appear so stable on the dashboard. So the future of GÉANT operations. Dashboard. Actually, GÉANT operations are quite much, I would say, impressed by the implementation from the Lola team, and also are looking into moving the TWAMP tests directly in between the Juniper routers. So there is currently an initiative, a task that's running, and I believe these routers that are unavailable now are part of that upgrade process. There is this extension being added there so that the Juniper routers will have full featured client and reflector on them, and we will be able to run these TWAMP measurements in between them. And also we'll be looking at GÉANT operations in having that solution with Grafana and Elasticsearch. The latest news is that the team is also considering moving to InfluxDB. So now I come to my last point, my last slide, with the possible future improvements. The first one is obvious, and I mentioned that already on the measurement details page. It's the collection of the TWAMP measurements results for all of the results, similarly like what the Lola team does. This is already an open ticket. We are considering that. I am also part of the persona development team. It's been well discussed. Unfortunately, there is a complexity to it, and most likely it will include many or all of these components, like the pscheduler server, pscheduler test plugin, and the archiver plugin. But yeah, we have an open ticket on that, and perhaps, yeah, even on the GÉANT side, we can find some effort to contribute there. Some of the, as a last point here, one observation, perhaps the community also would find that interesting or useful. I'm not sure how easy or complicated is that, but to have background multi-tests for TWAMP, something similar to OWAMP, and to have background multi-tests for the round trip time, for the ping tests, because that would allow me to run these ping tests even every minute, and it would allow for a better understanding of of the latency and loss, and it would be a really cheap kind of solution, because it doesn't require also that sort of time synchronization as the one-way delay measurements. And there are a lot of tools, already doing that, like Smoke Ping and the others, of course, but still being able to, that would increase the footprint of perfSONAR, and having round trip time measurements as background multi perhaps would be a benefit for all. So that's all from me. Thank you for your attention, and I'll be there.
Thank you, and perfect timing. Now is the time for the next presentation that we have, but I would like to ask Mark, because he put a couple of comments into the chat, just to say this. I think it will complement what Ivan just presented, and I think in this case it is better not to wait for the Q&A session.
Sure. You want me to I'll kind of recover what I said in there. Early on, we made the decision to make the latency test normal rather than background, and it was kind of driven. We talked to some of the people who were doing measurements, things like that, and the consensus was that it was better for if you're doing a one-shot latency measurement, you're probably doing it on purpose, and you probably don't want something that's going to be distorted by an ongoing throughput test. So that's kind of why we made that decision. And the rationale behind making the streaming latency, or the latency BG stuff, run background multi is that you could correlate, if you see odd measurements in your latency, you could correlate it with a throughput running at the same time and go, oh, well, that was probably because we're running throughput, and the latency tool was fighting for interface time versus anything else. Unfortunately, all this decision making came before TWAMP was even on the radar, and unfortunately at the moment we don't have anything that's sort of the equivalent to PalStream for TWAMP. But one of the things that's on the long-term that's on the sort of the long-term projects list is a replacement for PalStream that will, among other things, support TWAMP as well.
Thank you, Mark. Okay, so we will have the discussion about this presentation after the second presentation in this second session. So now the next speaker is Marcos Schwarz from RNP from Brazil. Good morning, Marcos. Okay, I see that you already shared the presentation with us, so please start with the presentation.
Okay, can you hear me?
Yes.
Okay, so thank you for the opportunity. Today I'm here to present our RP experience with perfSONAR. I'm R&D manager of cyber infrastructure, and we recently joined perfSONAR because it's part of some of our core monitoring process at RNP. I'd like to share our experience with the project that goes all the way to the beginning. So initially about RNP, okay. We are the National Research and Education Network from Brazil. We are composed of 27 points of presence that connects all the states of our country. And we also help to build the community networks that are responsible for metropolitan regions in the country. And also our goal is to connect more than 800 institutions around the country of education, research, and innovation. Since 2002, we started joining an international working group on monitoring. And we started this collaboration that was the initial group that started to develop perfSONAR. And since then, we have been working more focused on RMP needs. And this group have also diverged to different needs up until 2010. And from then on, it was very clear that most of the contributions of each individual team were very similar. So there was an initiative to start to work on a single open source project that is the current perfSONAR implementation. I think it started somewhere between perfSONAR 3.0 to 4.0. And we were not prepared on 2014 to join this collaboration. So it took a detour and started to go back and see how could we try to maintain our services, and in the mid-term try to converge with the same initiative of the whole group. So then we started to rewritten our tools, try to from the bottom up, try to adopt the components. And then from that on, we also started to internalize the team. So we're using a lot of external developers for our initiative, and we could try and then could adjust that so we can have a more long-term contribution and also retain the knowledge and have more control of our contributions to the project. And finally, in January 2021, we were ready and we started joining the initiative as a lead institution. So now we are fully on board, and we're really glad of making our contributions more effective. So our motivations for doing this is basically, we know there is a lot of effort involved in maintaining monitoring tools for specific needs of the research and education networks. And in that case, we want to either help with the troubleshooting, the testing, the user community, and also adopting a more rapid evolving set of tools. Also, RMP has already adopted perfSONAR for some of its core operation processes. For example, we are responsible for the procurement of the access circuits to all those 800 institutions that we connect. In this case, we have a process of doing circuit testing validation. So before activating circuit, we run some tests for 24 hours and try to see if the results match what has been contracted. And also the ping mesh of tests of perfSONAR used for calculating our network availability, and some performance indicators that use yearly to justify RMP results to our contractor, the Ministry of Technology and Science. And also we think that being part of perfSONAR is strategic to RMP because you're part of a global community that has a lot of experience with either serving the community or also following the technology trends and adopting them. So regarding the MonOP service, it's currently our perfSONAR deployment. We use it to diagnose and aid some troubleshooting on our backbone, and also to some of our communities, our client institutions. And also we adopt currently perfSONAR as a component, and we do some very specific tunings or different portals for specific audience, but that's something that we're trying to contribute back to perfSONAR in the midterm. Our target audience are network engineers and network researchers, as some operators, network operators, some universities and researchers, and also some projects for high throughput transfers and for some specific needs. Our current deployment, we have a central node for managing our 27 measurement points, each on one at each the point of presence, and we use that to create a full mesh of measurements for latency, for throughput, and trace route. So the service or architecture, as I said, Other than perfSONAR, which are the green boxes, we have the central management in a VM in the central place. And also we have this circuit validation portal that I will explain a little bit more how it works. And also on the POPs, we have a host with different containers for running the recurrent measurements from perfSONAR, the circuit validation test, and also have an NDT server from MLab to run some speed tests. There's some specific needs that we currently have. So our services are the normally known perfSONAR measurements meshes. So this one is the ping test that we do from the 27 to 27 point of presence. And this is what we use to our reports. Other than that, some specifics that RNP has, we have implemented this simple front end, and we are powered by the NDT in the same host with specific NIC and resource allocations to have some, I would say, tests from our end users. So they can test to each of the POPs and see how well they are doing. And this is useful for some specific use cases where you don't have a perfSONAR host on where the user need to have some troubleshooting information about. Regarding the circuit validation test, we run 2 perfSONAR tool containers on the same host, and we force a loopback test to the CPE, the customer premise equipment, that is the last equipment inside the client institution. And we try to validate if the circuit from the CPE to the point of presence has the specific characteristics that we need. So this test we currently automate with Ansible, and we're trying to contribute it to as an official perfSONAR test so that it can be orchestrated by pScheduler, and we're almost there. So after the end of this test, these are long tests for 24 hours on not yet activated circuits, so they don't have background traffic. So you can have a very clear result of the throughput, the latency, and if it is meeting the requirements of RNP. So it's less than 0.01% of loss, if it's less than 10 milliseconds of latency, and if it reaches 95% of the contracted bandwidth. In this case, it's 100 meg circuit. And then we get a report with all the met or unmet criteria, and that can be used to talk to our contractor and see where is the problem. So RNP contributions to perfSONAR, we have contributed this containerized perfSONAR deployment that we have, that it has better maintenance and automation support. It's made for long-running infrastructure. The previous perfSONAR container was more focused on testing and just experience how beta testing perfSONAR. So we already contributed that. And we've also been working on some new contributions. For instance, this loopback test that I said, so it could support circuit validation using pScheduler and having a less custom development code. And this test is useful for the community because it runs in the same host, the client and the server. So you can try to make a single host test. So you can do throughput tests to network devices using some specific network configuration. And then we can try to test those 800 circuits without having to have one tester in each point, what we are not able to do right now. And also we are early adopting new stacks and components from perfSONAR. So we are trying to use the new archiver and front ends. And the idea is to help to make them stable and being able to contribute them back to the whole community. Also, our team structure, we have as a steering member, our R&D director. I am the lead participant. We also have 3 developers, Danielle from RNP and 2 undergrads from the Federal University of Bahia. And for operation teams, we have Daniel Marquez, which is also an analyst at RNP. So I'd like to thank you for the opportunity, and we'll be available for questions later. Thank you.
Thank you, Marcus. Well, I have one question for you. You presented on slide 11. This is some sort of report about the link. Is this some formal test that is being defined by some regulatory body, or this is something that is internal to RMP that you created and you are testing for PerSONAR?
I think it's based on some RFCs, some part of the requirements, but we have an internal document that we use for the procurement process that defines a standard for each kind of circuit. So this is basically, we try to provide that same parameters for a standard test. It's not as standard as we would like to have around 20 different templates, but the idea is to try to convert to a single testing checklist that could try to validate all the type of circuits in as easy way. So currently we're working on that. Yeah, and the idea is that you could also customize our testing procedure, but mainly we have a long-running TCP, long-running UDP, and some short tests for verifying some known issues.
Thank you. Well, okay, now we are entering the Q&A session for this session too. So I would like to ask the audience if you have any questions or comments related to especially the two presentations that we heard in this second session, or anything else that we heard so far today.
I see the question from Brian. Actually, me myself, I don't have access to these to the Juniper routers, and perhaps.
I will interrupt you first, Ivan, because we're doing recording of the session. So I will repeat the question from the chat here. So it's coming from Brian Tern, and he asked how much CPU usage does TWAMP on those Juniper routers causes?
So I'm not able to respond to this. Perhaps if people from operational center are there, but in the call, but actually, yeah, that would need someone to go and look into this. I have no numbers about that. I have no idea.
Hello, Ivan, it's Darren. As far as the actual TWAMP tests themselves, they're handed off to the peer field, the line cards for processing. So the actual routing engine CPUs aren't doing that much with them. I can't give you the exact figures, but it's not zero, but it's not a huge amount.
Yeah, OAMP and TWAMP are in general are not particularly compute intensive. It's really sort of it's mostly just sort of get the data in from one end, look at the clock, put some timestamps on things, and send it back. So it's not a real barn burner by any definition.
Ivan mentioned in his presentation and presented the calculation of the amount of time that PS devices are spending sending the tests, and I understand the methodology, but I don't think that this is a huge issue in case of OAMP and TWAMP tests, because these tests are not creating a huge, they don't necessarily have to create a huge amount of traffic, although you can configure it that way. But I wonder, what is the, do we know, and does anybody know here, what is the greatest mesh that we have using PerSONAR, and has anybody reported anything about the collisions between the tests and the effect of overlapping tests, if that happened anyway? But I'm not thinking there about the throughput test, which I understand can create even a congestion on the link.
Pavle, I'm not sure about the greatest, which is the biggest mesh. Just wanted to mention that it's not about the traffic that these tests generate. It was about the schedule time that they reserve on the perfSONAR node, and with the 10-second test, it would result to 1/3 of the time. You see, and that's the problem, because that then means that 1/3 of the time is taken from the node, and then for the other 2/3 of the time, the other tests are competing. It's not about the traffic, it's about the schedule. Yes, but I guess I'm not sure. I've seen very huge meshes for WFCG.
Yeah, they're the big one. I think they're 125 on a side these days.
And this is not creating any issues with the scheduling. And
well, yeah, there's enough there's enough time in the timeline to get in all the testing that they're doing. I'm actually working with them at the moment on and I'll talk about this a little bit in my talk to, oh no, I'm sorry, this is not tomorrow's talk, this is a different talk somewhere else. I'm actually working with them at the moment on some things. They have their workload has actually gotten big enough that Python's multi-threading model cannot keep up with it anymore. So I have developed some things to take that work and spread it out among processes that have more reasonably sized thread pools in them. So we're kind of in the middle of alpha and beta testing that at the moment, but it looks pretty promising. And we're going to take that and also do basically all the once that works out, all the other the runner is the problem that they have this is the thing they're having trouble with. But what we'll be doing is once the solution to the problem is once I'm good with it, all the other multi-threaded programs in pscheduler will have the same thing done to them. So that way, at least, if you have more cores, you'll be able to take advantage of that. But yeah, I guess if Yvonne's problem is really, is temporal, there's not too much you can do about that, short of, as Grace Hopper used to say, if your problem gets too big, you don't get a bigger computer, you get another computer. So that's kind of the way that would have to go. I don't imagine, and this is just sort of a pie in the sky off the top of my head thing. I don't imagine it would be difficult, for example, if you had expanded to 2 machines, it might not be difficult to develop something where that spreads the work out. If you have like 2 machines in the same POP, for example, there might be a way to load balance that. What else can I mention on that? I guess the only other thing that's worth mentioning is the perfSONAR nodes that we run, or that IU runs on our behalf, are actually scheduled not so much by pscheduler. They have this thing that's sort of that is aware of the topology of the network and actually plans out the throughput schedule so that we don't have 2 tests running across the same link at the same time. And that's worked out pretty well for them.
And they're not using pscheduler for that.
Well, they are using pscheduler, but what they do is they lay out a schedule that says we're going to do this test at 2:30 and this test at 2:34 and this test at 3:15, and they actually tell pscheduler, I want it done at this time specifically. So pscheduler actually still it still oversees the measurements and archives the results, but it just gets told, here's when you're doing this, as opposed to go find a slot in the schedule for it.
And about the WSG mesh 125 to 125, I guess that's an OAMP mesh, right? I mean, it's with the background.
Yeah. I don't know that they're doing throughput that big, and I'd have to, just the machine that I'm working on is pretty well loaded, and even you know, I mean, it's obviously it's continuously producing latency measurements, but it does produce a good number of throughputs and RTTs and traces. So I haven't looked at their mesh too closely, but they're doing a lot with it.
Yeah, I do know they have a class of throughput test too that they run like every 24 hours. Like they've spaced out the throughput test, because I remember we've had to help them for hitting the P scheduler scheduling horizon before, because they were scheduling throughput tests so far out. So they do some stuff like that, I know, as well, to help with the load.
Yeah, if you want to see who's pushing P scheduler's limits, it's usually WLCG.
Thanks. Do we have any other comments or questions related to this session presentation? Well, okay, if not, then maybe we can have an earlier break. I see that Doug and Phil are here, so would you mind if we move the third session for 10 minutes in advance, so not to start at 4 Central European time, but at 3:50? Is it okay for you?
Yeah, I'm fine with that.
Okay, perfect. So then we will have another coffee break, and we will meet again in 25 minutes from now. So thank you all, and see you then. Good afternoon for the people in Europe, and good morning for the people in the United States. It's 15:50 Central European summertime, and we should start our last session for today. The first presentation is from Doug Southworth from Indiana University about some use cases for troubleshooting using perfSONAR. So Doug, I see you're here, and please start to share your presentation. Start with it.
All right, thank you very much. Let me share my screen here. Can you see that?
Yes, and
okay.
We can hear you.
So I just wanted to take a few minutes to talk about a couple of use cases that I was personally involved in, where perfSONAR was used to troubleshoot some fairly thorny network issues. A lot of times we have people set perfSONAR up to participate in a mesh and to track performance over time, which is always valuable, but it's good to remember too just how nice it is to have these nodes that are available in the wild that you can test against and you can prove out networks against, and actually be able to help researchers and people in different situations move their data more efficiently. So the first one involves some packet loss and poor performance from City University or City College, New York, to basically a university over in Japan that is connected to JGN, which is one of their large test beds. And they were doing this over a GRE tunnel. So representative from JGN actually contacted CCNY and said, hey, we're noticing some really, really poor performance only in one direction. Can you take a look at that? And researcher at CCNY noted as well that didn't have any actual measurements at the time, but noticed that file transfers in one direction were taking a lot longer than they were taking in the other direction. So this was from Cayutech Institute, like I said, kind of connected to that JGN test mesh over there. So from JGN to CCNY, there was no packet loss that was measured, and there was about 79 megabits worth of throughput. And they gleaned this data solely from using iPerf. They weren't using perfSONAR at the time. There were no nodes that were available to use at CCNY. And testing back the other way from CCNY to JGN, they were noticing a pretty consistent 0.082% packet loss, and they were only getting about 8 megabit of throughput. And that was actually about the best performance they saw. Typically, it was slightly worse than that. What was interesting, though, is before we even set up perfSONAR, they reached out to the EPIC group, which I'm a part of, which deals with these kinds of network issues and basically acts as kind of a center for coordination among different groups that are necessary to solve these large multinational, international transfers. So on a lark, we said, hey, go ahead and test UDP performance just for laughs. Turns out UDP wasn't affected. Very symmetric performance, basically 90 megabits either direction. And we didn't actually have a target number that we were shooting for. CCNY or JGN, either side didn't tell us, hey, we should be getting a gigabit. They basically just thought that the performance both directions should be symmetric, and testing via UDP kind of showed the same thing, that symmetry was possible, that there's something else going on underneath the behind the scenes. So since there wasn't perfSONAR available at CCNY, at least initially, what we did is we picked a series of nodes that we happened to know were on the same path from a network and geographic perspective as the GRE tunnel that was going to Japan. So the near perfSONAR node in Manland there in New York was the basis for these tests. And so we tested to I2's node in Chicago, to the Transpac node in Seattle, and then over to one of the APAN nodes that is in the same region and connected to the same networks as the JGN testbed. And all of those tests came back normal. We didn't see any packet loss, throughput looked good. So we knew we had to look internal to CCNY and maybe possibly the regional network there that before it connected to some of the major backbone links. But we were able to, at least initially, give information to CCNY and say, look, we're going to have to look a little closer to home to actually see what's going on. And we didn't have to have a specific node up and going at CCNY to start the troubleshooting process. So once we had that data, we went back to CCNY and we said, look, we really need a perfSONAR node in your lab. And they were able to set one up. And actually, I had to pull Mark Feit in on this temporarily, because initially they were having problems with their perfSONAR node. Ultimately ended up being related to the node was under provisioned. It didn't have enough memory. And as soon as they added, they went from 2 gigs of RAM to 8 gigs, everything cleared up and worked perfectly fine. So testing from inside of this researcher's lab to those same perfSONAR nodes outside in the wild showed the same packet loss. So we knew that the packet loss was not limited to the GRE tunnel, that it wasn't something specific with that encapsulation that was going on, that there were connectivity issues just in general from this lab to the outside world. So then we pulled in NREN. So NREN is the regional REN that provides connectivity to CCNY. We pulled in a couple engineers from there, told them what was going on, and it just so happens that NREN actually has a perfSONAR node that is attached to the same router where CCNY connects to NREN. So we broke it down into that chunk. Can you get from the campus to your regional provider without any packet loss or connectivity issues? It turns out that they couldn't even get that far. The testing showed the same packet loss that we had been looking at. And we actually found on the ingress path to CCNY, we found MTU issues and packet fragmentation, that jumbo frames, we had things set to the MTU set to 9,000. That those packets were not consistently, but it wasn't every packet, but some of the packets going through were getting fragmented or jumbled and cut into smaller pieces. So we had some odd issues where it wasn't an MTU black hole. Packets weren't just disappearing, but they were occasionally being fragmented in weird ways. But NREN got back to us and said, look, we've tested to their campus, we've tested to this researcher, and we've also tested outside to other places that are connecting to us, and we're positive that this problem is on the CCNY campus. So we go back to CCNY with all this information and say, look, we really need you to start scouting around, possibly building to building or logical connection to logical connection point, however that looks on your campus network, and see if you can narrow this down. So we gave all the information we had back to CCNY to do some additional local troubleshooting. And it turns out they found an old outdated security device that was just ahead of the research lab that was having the problem. And that network security device had actually already been scheduled to be replaced. I don't know the exact timeline they had for it, but because of this data that we were able to find using perfSONAR showing that it was causing issues with transfers, they actually expedited the replacement of that equipment. And I think it was within 2 weeks, they had the new equipment installed, configured, up and going. So the final result of that encounter was no packet loss in either direction and a very symmetric-ish 80 to 85 megabits worth of throughput within the margin of error. UDP performance remained about the same at about 90 megabit, a little less overhead. But basically the outbound problem from CCNY that we were experiencing had been solved, and it turned out it was just a piece of old network equipment that was not handling the traffic very well anymore. So it was interesting because there's a few takeaways I took from this one. First of all, that using perfSONAR outside of the network in a logical and geographical path along the route that the initial trouble was occurring in allowed us to do some troubleshooting without involving the campus directly or without having to involve network engineers and say, we need you to install a node. We were able to go to them with some data that said, we think the problem is on your campus based on this. Could you help us out? Could you install a node? Could you give us some more insight, a little further into your network? Also, that testing with different protocols can definitely aid in diagnosis. In this case, it wasn't particularly valuable, but it did point us towards it being a possible hardware issue or network configuration issue, since one protocol was working and another was not. And that partnerships and data sharing are definitely essential when you're troubleshooting a large issue like this, to be able to work with the researchers and the campus network folk and the regional network folk and people all the way on the JGN side in Japan. All those people came together and were able to share data and solve a network problem that honestly was buried fairly deep and a little bit hard to find, and probably had gone undetected for some amount of time. It's impossible to say how long it had been there, but my guess is that it hadn't just occurred, that this had been there for some time and people just didn't know how to deal with that. So I'm about halfway through my time, which is perfect because I've got one more example. So routing and congestion over at Iowa State University. So we had a performance issue between Iowa State University, specifically a researcher in one of their buildings. I think it was the agronomy building, and UCAR, which is the University Corporation for Atmospheric Research. So that's a large co-op of over 100 universities that all come together to share and study weather and atmospheric related data, and they are headquartered in Boulder, Colorado. So the climate researcher there needed real-time NOAA Earth observation data, and this data was fairly large in size and you needed a decent connection. He basically told us, look, I need 80 megabits of sustained throughput to do these observations. And that gave him a lower resolution than what he really liked. Really, he was hoping to get 320 megabits of sustained consistent throughput when he was accessing these observations. But performance had been degrading over time, and we were seeing dips as low as 32 megabits, and sustained rates usually were no better than 50 to 60. So we'd had kind of a fall off over time, but even at the outset, it was getting anywhere towards 320 megabit wasn't really realistic, according to this researcher. So this researcher talked to Epic, once again, one of the projects I'm involved with, and we talked him into installing, again, perfSONAR on the file transfer server in his lab. So he actually had his own small DTN in the lab that he was using. We got him to put perfSONAR at the endpoint. I mean, so as close to the end as you can possibly get. And the bandwidth test looked pretty good when you were going from ISU to UCAR. Upload was not an issue. But on the way back through, we had a ton of packet retransmits, and the performance was just really, really terrible. When we started looking at tests, TCP windows weren't scaling. As soon as it tried to ramp up and increase the TCP window, there'd be a bunch of errors and it would shut right back down. And there was just no good way to get data through with as many errors as we were seeing. We also noticed that the route out of the campus was different than the route back into the campus. And it seemed to be inside the campus itself that route change was occurring, not out in the wild. So we went back to the CI staff and we told them, look, we think that there's something going on your campus network. Can you tell us if there's been any changes to your connectivity recently? Because while this researcher was saying that the performance has never been great, just very recently in the past month or so, there's been a large performance drop off. And so it turns out that ISU gets their connection from GPN, and really GPN is just providing an Internet 2 connection to their campus. And we also started, when we had them look a little bit deeper and do some testing of their own, we saw that jumbo frames, similar to the CCNY case, were being dropped or fragmented. And based on our advice, we went ahead and asked them to install a couple more perfSONAR nodes, which they were amenable to doing. So as opposed to just having perfSONAR at the researchers and then clear out at UCAR, they ended up putting building and campus level nodes in to try and further isolate the issue. So we got a little more perfSONAR saturation, if you will. So based on all of that, we were positive on the data that they had uncovered that the problem was specific to the ISU network. So ISU engineers went through, did some additional testing. They found some really outdated firmware and operating systems on switches and routers. So they went through and they got everything back up to date, and that made a little bit of a change. Things got a little bit better. They found one piece of bad equipment that didn't work particularly well. It was not passing traffic, and I think the actual core issue of this one, if I'm remembering right, was it had very small buffers. It was an old switch that had almost no buffer to it, and trying to transfer data farther than a couple milliseconds away, it would just start to fall on its face. So they replaced one piece of equipment, one old switch gear, and they made some configuration changes along the path. Some of the network gear was not configured for jumbo frames, and some of it was. And obviously, if you want jumbo frames end to end, every hop along the path has to support jumbo frames. So they made some changes there as well. We started making a little progress. Bandwidth looked a little bit better. We still didn't see the amount of bandwidth that the researcher wanted to see. So we went back to testing, and working with the ISU engineers, we found out that they had a 10 gig link that GPN had provided them to Internet 2, and it was really congested. They didn't realize how much traffic was going in and out on this link. And so that actually spawned the university based on the data provided by perfSONAR. And I'll pause right here and say that this was data that had been gathered over the course of a month or so. So this problem wasn't solved in real time. I mean, it sounds like we solved this thing in a half hour. Realistically, this was a couple months of work. So they gathered some historical data, and they found out that that 10 gig link had been used and really was congested more often than not. So they went to GPN and got an upgrade, and now they have a 100 gigabit link coming into the campus. Further study into how the switchgear was behaving in the agronomy hall based on consistent, again, over time, perfSONAR testing, showed that they just had a lot of outdated switch gear, and that the one piece of gear that they had replaced wasn't enough. So they actually found some money, and over the course of a couple of months replaced the entire switching infrastructure in the agronomy hall, which had just been, it was good equipment, but it was old equipment. The routing asymmetry that we found actually was contained to the campus as well. So data was going one way into the agronomy hall, and it was coming out another way. Once they realized why that was happening, they were able to normalize that routing, so data always took the same path through the campus. So at the end of all of this, so this represents a total of about 5 to 6 months of work where they had time to look at it, and then we'd back off, and then we'd do some more study, but it took a little while to get this done. Average transfer rates for our researcher are now consistently over 600 megabits per second. And he, once again, can finally access his real-time data. And since he has more than the 320 megabits he was hoping for, he can get the highest resolution, best quality data possible, as opposed to at 80 megabits, he really was still sort of limited in his research and how he could proceed with that. So just another couple takeaways from this one. What seems like a simple problem can be multiple problems. In this case, it wasn't just a lack of bandwidth. It wasn't just a bad patch cable or a dirty fiber. It turns out that there was a routing issue, that there was congestion. It was a bandwidth issue that was not confined to the building. It was actually a campus-wide, and that we had MTU settings on different pieces of gear that didn't agree with each other. So it wasn't one simple problem, it was a multitude of problems. And perfSONAR helped us go through and pick out each of those individual problems. And as we'd fix one, we'd move on to the next one, which I guess working with networks is kind of like being a plumber. If you've ever replaced old pipes, you know that as soon as you touch one rusty old pipe, it, you know, the next one down the road breaks. And this problem kind of felt like that. So eventually we had to do a lot of plumbing to get this fixed. And even when the network, quote unquote, worked, the performance could have been better. The researcher had never been able to get 600 megabits worth of throughput. And so while things were working at a level where he could barely do his work, it wasn't until the performance really fell off and he couldn't do his work at all that the problem got addressed. But being able to see performance data over time would have been really valuable, because we probably would have been able to see this problem before it got to the point where the researcher couldn't do his work at all. So while this was super helpful for troubleshooting in the wild, the value of perfSONAR to gather that data over time is also really valuable in terms of maybe heading some of these kinds of problems off at the pass. So it looks like I am right at time, and I will stop sharing.
That indeed perfect timing. Okay, so now we will move to the last presentation for today. This one is from Reese from Stanford University. So Phil, please share your screen and you can start your presentation.
Okay, I'll start. Let's see. There. Okay. So what I'm going to talk about is very not low level, but lower level than what the conversations have been so far. It's really kind of an introductory use of perfSONAR and Mad Dash. And I think of this as maybe something that people might want to use to introduce an intern to how the inner workings of perfSONAR and Mad Dash work. So what I want to do is I have put together a GitHub site, and it has a bunch of lines that you can paste into a machine. And we're gonna, I initially planned to make that, to paste it in now and to watch it build as I presented, but a little too risky. So I have a copy of the output, and the servers have been built. So we'll get to there. But why do this? Well, one of the first things is that when I first started looking at perfSONAR issues, the first view of perfSONAR that you see, of course, is, or almost always, is this type of view. And when we've completed
Phil, just a second. The slides that you're showing are relatively small. I don't know why. Is that, are you sharing the whole screen, or you're sharing just the application?
I'm not sure I can answer that.
Because it's impossible to read.
Okay.
Just for info, in the chat, I've posted the link to the presentation, which is on the wiki. So maybe if you would like to look at this presentation and follow this in parallel, so that.
Yeah, maybe you can stop sharing and try to share it again, but now as an application, just to share this screen.
I'm not sure what this screen means, but.
Because we can see your mouse, so this means that probably you're sharing the screen, and it's a wide screen. So
yes, it is a wide screen.
Somebody else could share it, and Phil could just say next slide, please. That's not a possibility.
But I believe you can stop sharing, and when you click on the share screen, not share the whole screen, but share just your app with the presentation. I don't know if this is PDF or PPTX.
Phil, if you run that in a window and share the window, that might work better.
Yeah. And how would I do that? So I'm on the desktop. Do I say desktop?
Is that PowerPoint, Phil?
It's Google Slides.
Oh,
when you click
yeah,
share screen, then you will see a picture, a lot of pictures, and in one of these will be just this presentation that you want to share. So you should maybe try to choose that one picture which is which contains just your presentation, not the desktop.
Yeah, I can't see what you are seeing. Did that change anything?
Because you need to stop sharing first.
Okay.
So when you go to present, Phil, it will by default make it full screen. But as soon as it goes full screen, if you go move your mouse down to the lower left-hand corner, you'll see a little menu pop up, and it will have an option to. You'll see a little kind of looks like a collapsing window to make it smaller, and it will stay presenting, but it will shrink it down to a window.
Got it.
And you can share just that window.
Okay, let's try this. Nothing good happened here.
Yeah, if you hit the three dots there on the far right,
yep,
you should be able to exit full screen.
Okay, I'm sharing it now. So maybe we can do it this way, and
sure,
you can just tell me when to when to move it to the next slide.
Okay, so this is the typical screen that most people start, and was certainly the screen I was first introduced to perfSONAR. And but very shortly after looking at this, we would see a screen like the next slide. Next slide, yeah, and that would be in this case, ASNET's large mad dash grid. And you go, whoa, how do we go from this simple, straightforward one by one view to a multi-mesh, full mesh like ASNET. And next slide. And of course, it gets even worse when you look at all the different dashboards that are available off the ASNET. Many of your dashboards also have many dashboards as well. So it seems to be a daunting problem to the neophyte entering the perfSONAR space. Next slide. And so, you know, where are the answers? Well, the ever popular docs, perfSONAR.net, of course, has all the answers, and it does. But boy, there's a lot of information packed into those pages, and even reading hours and hours, it doesn't solve all your problems. In fact, it doesn't really give you the point A to B to C to D. It gives you what A is all about, what B is all about, what C is all about, but it doesn't, to me, it doesn't provide a good linkage between A, B, and C. Andy and the perfSONAR team in general kind of got that idea and put together a brief one-pager a few years ago and have kept it up to date. It's still in the perfSONAR documentation, but it's only one link off the main table of contents page. So I'm afraid that many people don't see it because as you step through the pages of the docs, you never get to this page. But anyway, in the lower corner, you can see the beginning of what the page looks like. And basically, Andy put together a very nice step-by-step process to go from to build a mad dash configuration management site and to build the edge nodes to feed it. Next slide. So what I did is I wanted to take advantage of that and make it more visible. So I put together a project that I'm calling perfSONAR Sampler. So it's like you know, an alphabet sampler as in grade school of just how to put all the pieces together. And what I did is I then thought, well, how can I present this better than on a Google Doc page? And I was playing around with other tools, and Vagrant, Ansible, and GitHub all came to mind. And I put together a project that integrates all of those and the perfSONAR development document, and made a little project that creates 6 nodes and a MADASH server, and it puts together a full mesh and a disjoint mesh, and it all builds in about 15 minutes. And it fits on one small server. And it was just, it obviously isn't doing any network, real network management, but it does illustrate how the build process works, what the JSON files do for the project, and how it all fits together. Next slide. On the left there, you can see my small Nook that I've used. It's almost worn out from the number of times I've rebuilt it and handled it over time. In order to get the VMs working on that and doing perfSONAR work on VMs, I used a external dongle for a second Ethernet interface. So I have the main interface to the main network to the Nook. I have a second one that actually doesn't have an IP. It just serves as a bridge to all of the servers that are on that box, all the VM servers that are on that box. As part of the process, I had to choose a bunch of IP numbers, and that moves over to the box on the right-hand side. I had to put a table together of what was needed for the project. One of the things that I tried to do is to make it as straightforward as possible. If I could use DHCP and DNS, local DNS, I could make things much more simpler, much more generic. But because I didn't want to do that, I wanted it to work on anybody's machine. I had to put together this table, and the table contains the information needed for the build process. Let's go to the next page. This is supposed to build, but that's okay. So the first point at the very top is the name of the external dongle interface. Unfortunately, or the reality is that external dongle has got a very long interface name. That's important to write that down on a chart, as I suggest. And then I also need a range of IPs to use, an IP segment, I should say. And so, because I built this at home, I used my full network /24. Could be anything you want, but you just need to write it down so you know which one to use. And then I used 7 IPs. I happen to have a block of 7 contiguous IPs in my range at home. Doesn't have to be that 7, but it does need 7. And the MAC addresses are interesting. Again, learning from myself. I realize now that virtual VMs generate their own MAC address, and the leftmost 3 quads are the same, and the rightmost 3 quads are variable. But having them sequential doesn't make any difference, because you're never going to run into a conflict. So I just made them consecutive like they are there. Now, to use all this, I had to be sure that these are added to the appropriate files. And so the appropriate files are indicated at the bottom there. And we'll look at that as we get into looking at the files that are used to build this project. Next slide. So here's a diff of the 2 JSON files. The one on the left is the full mesh JSON file. It's just 3 hosts by 3 hosts, but it illustrates how meshes are put together. The slide on the file on the right is a disjoint file, and it just shows highlights a little bit of the differences. They're essentially the same file, just with some of the content of the servers, nodes changed. This is where you'd want to make some of the edits. You'd have your chart here, and you make the edits to have the files reflect the chart that meets your configuration, not my configuration. Next slide. So new to this open source tool thing, Vagrant file was a Vagrant tool, and Vagrant file was quite the eye-opening thing when I realized that I could build these 7 nodes and this few lines of text. It was pretty eye-opening to me. And this too is where you would make the significant number of changes needed to match your chart that you're putting together, that you put together originally to make this all work. Vagrant is quite interesting, and as I said, I'm a novice at it, but it's been pretty eye-opening for me. Okay, next. Okay, the other open source tool used in the project is Ansible. This is nowhere near the sophistication of Ed's Ansible tools that he's using at his university, but it is just a way to show you how to use Ansible to build these machines quickly and in the background. The characteristic that is particularly valuable is that it shows the actual perfSONAR lines, or sorry, psconfig lines that have to be submitted to the servers to alert them to the jobs that they're to do and other things. So this is where people can go back and look and see how did you get the rate of the RTT test to not be 30 minutes, but to make it only 5 minutes. There's a line that shows how to make that change. And so that's what the value of the Ansible files is. It contains all that information. Okay, next file, or next slide. All right, again, this was a build, but the upper left quadrant shows what the example mad-dash grid looks like, and it shows that there's 2 meshes, two dashboards, the PS project and DJ for disjoint, and that if I choose the PS project on the right hand side, it shows you what the project looks like that got built, and again in this under 15 minutes time frame. And then back to the left, it shows what the disjoint project looks like, disjoint dashboard looks like. And I think next slide. So we're getting towards the end there, and I'd like to show some of these. Well, I'm reluctant to do it since I'm not. I retired from Stanford recently, so I'm not the expert of Zoom because I haven't been Zooming all year. So all of you are much more expert at having, because you've Zoomed all year. I'm not. But what it does show is some interesting things about a dashboard using virtual machines that, as I said before, are not obviously monitoring real network. But so on this one NUC running 7 machines, I get 25 gig connectivity between 2 of the mesh nodes. So clearly that's not happening, but what's happening is passing on the bus rather than actually over the network. So that was an unexpected outcome of the VMs all in one box. On the right-hand side, I'm not sure how this is going to work. Can you see if there's a click on the right-hand side in the black box?
Yeah, I can't do that. You will have to share it because I need an access to the Google Drive, which obviously you have. So I will stop share and I'll let you try to do it because I think that at least I hope this is going to be of all proper size.
Okay. Can you see this?
Yes, and if you can make it full screen, at least this video.
Yeah, I wish I could. I really don't know how to do it.
Yeah, I thought there is that box in the low right corner of the video. Maybe this can make it bigger, but
Probably didn't do anything, right?
no, no, no.
But now that you're full screen, if you want to share just that window that you've opened there, you can present it from just that window. So you can share the window instead of the entire screen in Zoom.
Yeah. And I would go to new share. Can you see, can you see where I'm pointing at? It's called desktop 1.
Yep.
And I would just do share.
Yeah, if you just click on screen share, and then you should see a variety of your different windows, and you can pick just the one that's got your presentation in it.
Any different?
It's better.
No.
If you can shrink the window down to, eliminate some of the top black and, top and bottom black bars. There we go.
Yeah, that's great.
Perfect.
Okay. I should have known. Anyway, the one thing I wanted to end this with is to talk about where this all went. So I got the idea for the mad dash, the aha moment from Andy's document, and that led to us looking at mad dash and doing it on campus. So what we did on campus was to put together a bunch of edge nodes that were at each router point across the campus and across the residential network. And then we watched that through this grid on that's playing on the right. And we can see the events happening across the campus. The idea is to find out what's going on network-wise across the campus before the users do. And this has worked out surprisingly well, but it has required some interesting technology. Basically, looking at the static screen doesn't tell you enough to help with diagnosis of any issues on campus. We needed to do a movie of the grid over time. And what we're seeing on the right there is that movie over time. And what we need to do is to watch the grid and see what happens. The up and down arrow, yellow that's happening there isn't a problem. It just shows that's a very busy part of campus. As we've learned over time, we can look at these videos and we can then determine where there are problems on the campus. So that has been a very powerful tool for us to discover latency problems and RTT problems and ping problems before the campus discovers it themselves. And that's about it that I wanted to talk about.
Thank you, Phil. So finally, we managed to show everything to our attendees.
I apologize
okay.
for the lack of skill on that.
I think it was great. So this was the last presentation for today. What we have in our agenda is the last Q&A session. So I would like to ask the audience to ask any questions if you have, either to write into the chat or just please turn up your microphone and ask your questions.
Doug, how did you guys capture that video of the mad dash mesh?
Phil, you mean?
Sorry. Yes.
Yeah.
Thank you.
Yeah. So I did a screen capture through Google. So every minute I capture a screenshot, and then I use another FFmpeg to stitch it all together. So at the end of the day, I have a day's window. But what happens when you want to look at during the day? Well, I also have another screen that has the individual slides throughout the day. I'm sorry, it's every 5 minutes, not every minute.
Thanks.
By the way, the screen grab from Google is a challenge. It often spawns a lot of different processes, and it was a challenge to get that under control.
Thank you.
Happy to share it if you're interested.
Do we have any other question from the audience? Well, if not, I guess we can then end this first day of the workshop.